most essential learning competencies. Explain physical changes in terms of the arrangement and motion of atoms and molecules. Change is happening all around us all of the time. Just as chemists have classified elements and compounds, they have also classified types of changes. Changes are either classified as physical or chemical changes. Chemists learn a lot about the nature of matter by studying the changes that matter can undergo. Chemists make a distinction between two different types of changes that they study: physical changes and chemical changes. It is important to understand the difference between chemical and physical changes. Some changes are obvious, but there are some basic ideas you should know. Physical changes are usually about physical states of matter. Chemical changes happen on a molecular level when you have two or more molecules that interact. Chemical changes happen when atomic bonds are broken or created during chemical reactions. Physical change. No change to molecules. Physical change occurs when a matter changes in state of appearance without changing its original composition. For example, if you shape a piece of dough into a round bread or square, or cut into smaller pieces, the composition of the dough remains the same. When you step on a can and crush it, you have forced a physical change. However, you only changed the shape of the can. It wasn't a change in the state of matter because the energy in the can did not change. Also, since this was a physical change, the molecules in the can are still the same molecules. No chemical bonds were created or broken. When you melt an ice cube, you have a physical change because you add energy. You added enough energy to create a phase change from solid to liquid. Physical actions such as changing temperature or pressure can cause physical changes. No chemical changes took place when you melted the ice. The water molecules are still water molecules. What if you dissolve sugar in water? When you dissolve sugar in the water, sugar will no longer visible but its property of being sweet is still present on the solution. Some physical changes are reversible like melting wax. Just let it cool, then it will solidify again. Wax has only changed its state, but its composition remains the same. Chemical change or changing the molecules. Chemical change occurs when matter changes its composition, which may result to the formation of a new substance. When a chemical change occurs, we can no longer determine the original property of a substance since the resulting new substance will have its own unique properties. Chemical changes happen on much smaller scale. While some experiments shows obvious chemical changes such as color change, most chemical changes are not visible. However, behind the scenes, billions of chemical bonds are being created and destroyed. For example, when you burn matches, they will turn black and become ashes. The change that occurred is irreversible, meaning you cannot return the matchsticks back to their original appearance and composition. Iron rusts when it is exposed to oxygen gas in the air. You can watch the process happen over a long period of time. The molecules change their structure as the iron is oxidized, eventually becoming iron oxide. Rusty pipes in abandoned buildings are real-world examples of oxidation process. I have here list of evidences of chemical change. Number 1, change of odor. 2, change of color. 3, change of energy. 4, change of composition. 5, light and or heat is given off. 6, formation of gases. 7, formation of precipitate. 8, decomposition of organic matter. And 9, change is difficult or impossible to reverse. Let's proceed on to phase change. Matter can change phases when thermal energy or heat energy is added into or released from it. What is phase change? Phase change is a change from one state of matter, solid, liquid, and gas, to another. It is a physical change because it only affects the physical appearance, not the chemical makeup. It is also reversible. What happens during a phase change? We have what we call endothermic and exothermic. When we say endothermic, the system absorbs energy from its surrounding, or the energy goes in. While exothermic, the system releases energy to its surrounding, or the energy goes out. This picture shows the three phase changes in water. We have solid, ice cube, liquid, water, gas, vapor. Take note that each change has an associated name and that half of them are endothermic, the red arrows, and the other half are exothermic, the blue arrows. Each change occurs at a specific temperature as well. Solid to a liquid and back to a solid. Imagine that you are a solid. You're a cube of ice sitting on a counter. You dream of becoming liquid water. You need some energy. Heat is probably the easiest energy you can use to change your physical state. The atoms in a liquid have more energy than the atoms in the solid. There is a special temperature for every substance called the melting point. When a solid reaches the temperature of its melting point, it can become a liquid. For water, the temperature needs to be a little over 0 degrees Celsius to melt. Melting is the process by which a substance changes from the solid phase to the liquid phase, like ice cube melting into water. The reverse of the melting process is called freezing. Liquid water freezes and becomes solid ice when the molecules lose energy. Freezing is the process by which a substance changes from a liquid to a solid, like sweetened cream into ice cream. Solid to a gas and back to a solid. You know about solids melting and becoming liquids. Some of you may have also seen a solid become a gas. It's a process called sublimation. The easiest example of sublimation might be a dry ice. Dry ice is a solid carbon dioxide. When you leave dry ice out in a room, it just turns into a gas. Have you ever heard of a liquid carbon dioxide? It can be made, but not in a normal situation. Coal is another example of compound that will not melt at normal atmospheric pressure. It will sublimate at very high temperature. Can you go from a gas to a solid? Sure. Deposition occurs when a gas becomes solid without going through the liquid state of matter. Those who live near the equator may not have seen it, but closer to the poles we see frost on winter mornings. Those little frost crystals on plants build up when water vapor from the air becomes a solid on the leaves of a plant. Liquid to a gas and back to a liquid. When you're a liquid and want to become a gas, You need to find a lot of energy. Once you can direct that energy into your molecules, they will start to vibrate. If they vibrate enough, they can escape the limitations of the liquid environment and become a gas. When you reach your boiling point, the molecules in your system have enough energy to become a gas. When a liquid becomes a gas, the process is called vaporization, such as alcohol turns into vapor. When vaporization occurs at the surface, it is called evaporation. When it occurs throughout liquid, it is called boiling. When a gas turns into a liquid, it is called condensation, such as water vapor changes into dew drops. When you reach the temperature of the condensation point, you become a liquid. If you were water vapor over a boiling pot of water and you hit a wall, the wall would be cool, absorb some of your extra energy, and you could quickly become a liquid. Cooler object often absorbs energy from hotter objects.